Hi, this is the topic of trigonometry for the International Baccalaureate course Mathematical Studies. So in this video I'm going to go through labelling sides, the trigonometric ratios. We'll look at how to find sides in a right angle triangle, how to find angles. Then we're going to look at angles of elevation and depression, three-dimensional trigonometry, and then we're going to look at non-right angled trigonometry, so area of a triangle, cosine rule, and then sine rule. In a right angled triangle, the hypotenuse is the longest side and it's located opposite the right angle. So here's the right angled triangle, and the side that is opposite that right angle is the hypotenuse. Now, we label the other two sides as either opposite or adjacent, but it depends on which angle is highlighted. So let's just get rid of this. If I highlight this angle here, then this one over here will be the opposite side because it's opposite that angle, and this side here is the adjacent side. Adjacent means next to, so it's next to that angle. If I highlight this angle up here, then they switch around. This one becomes the opposite side and this one becomes the adjacent. There are three main trigonometric ratios. They're sine, cos and tan, and they're defined as follows. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. And we use the acronym SOHCAHTOA to remember all of this. So this is what it stands for. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Firstly, we need to make sure the calculator is set on degrees instead of radians. This is really important. So we're going to do Shift Setup and navigate down to angle. And when you navigate down to angle, you'll see written here, currently my calculator is set in radians, and we're never going to use radians. There's actually another setting on there as well called gradients, but what we want is degrees. So down the bottom when you highlight it, you'll get degrees, radians, gradients, and so we're going to hit F1 for degrees. So let's look at how we find an unknown side. We're going to use the following process. So firstly, we label the sides of the triangle. Then we decide which trig ratio to use. Then we set up an equation, and then we solve the equation. Here's an example. Find the value of x. So in this triangle, I can see that I've got the hypotenuse. I can see that's because it's opposite the right angle. What's this side here in relation to the angle? It's the opposite side, so we label the two sides that we've got. Here I've written out SOHCAHTOA and I've highlighted the O and the H in each case. So can you see that we're going to use sine? We can't use cos or tan because we don't have the adjacent side. There's nothing written there. Now this is a little formula for us. It tells us which order to put the sides in. So sine of the angle equals opposite over hypotenuse. Sine 50 equals x over 14. That's my first line. Now it's just an equation that I need to solve. This is a divide by 14. It's going to go over the other side as a times. Now I've taken the liberty of turning this around, so I've got x on the left-hand side. So x is equal to 14 times sine 50. And I put that in the calculator in the run part of the calculator, so number 1, where you do all your calculations. And it will give me 10.7 centimeters. Let's try another one. Find the value of y. Okay, so let's label the sides. Here is the hypotenuse, and in terms of the angle that I have, this is the adjacent side. So I've got adjacent and hypotenuse. All right, let's write down SOHCAHTOA, and this time I'm going to be using cos because both sine and tan need the opposite side, and I don't have the opposite side. So cos of the angle equals adjacent over hypotenuse. So cos of this angle is equal to adjacent, which is y, over the hypotenuse, which is 14.2. Now again, I'm going to solve this equation, get y by itself. This is a divide by 14.2, and I'm going to take it over as a times. And I'm going to turn it around at the same time. So y is equal to 14.2 times cos 42.5 in the calculator gives me 10.5 centimeters. Now one thing you might find curious here, especially if you haven't done the IB in years 7 through to 10, is this angle being written with one decimal place, and that's the way they do it in the International Baccalaureate. We don't use degrees and minutes, if you remember that. So you'll often see the angles written to 3 significant figures. Be careful to follow the order with SOHCAHTOA because sometimes the pronumerals can end up on the denominator. Here's an example. Find the value of m. So we go through and we label the sides. In this case, we don't have the hypotenuse. We've got the opposite side and the adjacent side. So looking at SOHCAHTOA, we're going to use tan. And this tells us the order. Tan of the angle equals opposite over adjacent. So tan 62.1 equals opposite, which is 13, over adjacent, which is m. Now when we've got the pronumeral on the bottom, what we can actually do is just switch these two, but I'm going to show you why. So first thing I would want to do, if I was doing it the long way, would be move this m over. So it's a divide by m, it's going to go over as a times by. And then I would move this, tan 62.1, over the other side as a divide by, because you can see that times there. So it would become that. So can you see how that tan 62.1 and the m have swapped places? The m's become a times, the tan 62.1's been divided by. So we can go straight from this line to this one. Okay, they just switch places. Then we put it in the calculator and we get 6.88 centimeters. Finding an unknown angle is almost the same. It's just this time the pronumeral will be the angle instead of the side length. So you can see the difference here in this triangle. I've got 2 numbers on the sides, and this is a pronumeral. It's called theta, where the angle should be. We're going to do exactly the same thing. We're going to figure out what sides we've got and then use SOHCAHTOA. We've got the opposite side and the adjacent side. Do you remember which one that is? It's tan. So tan theta equals 18.8 over 22.5. That's our first line. Now, this is a little bit different, isn't it? Because I need to find out what theta is, and I've got this tan sticking there. What we've got to do is take the tan over the other side. And what happens when we do that? It becomes inverse tan. It's got a couple of different names. So it looks like tan with a little -1. So it's inverse tan. Some people call it shift tan, which is how you get it on the calculator, or tan to the -1. Now, on our calculator, above the sine, cos and tan, but in particular the tan, you can probably, hopefully, just see tan with a little -1, and you get it by doing shift tan. So we're going to go shift tan, in brackets 18.8 divide 22.5 like this, press equals, and we get 39.88063102. We only need 3 significant figures, so our answer will be 39.9 degrees. Let's move on to angles of elevation and depression. So angles of elevation and depression are names for 2 angles in real life situations. So from where you are looking straight out to where you're looking up at an object, that's called the angle of elevation. Similarly, from where you're looking straight out to where you're looking down to an object, that's the angle of depression. If you want to check this out, go to a balcony in a building and look straight out at the skyline, and then look up at an object. That will be the angle of elevation. And then again, look straight out and then look down at an object. That's the angle of depression. Let's have a look at an example. James is standing on top of a cliff which is 120 meters tall. He measures the angle of depression to a boat as 34 degrees. How far from the base of the cliff is the boat? So we're going to start off by drawing a diagram. You can see James there on top of the cliff and the boat out to sea. Now we know that the cliff is 120 meters tall, and we want to know how far from the base of the cliff is the boat. So that's going to be x. So we'll start by joining this up to make a triangle, and now we've got to find out which one is the angle of depression. Be careful here because a lot of people think this is the angle of depression, but remember I said it's from where you're looking out to where you're looking down, so it's actually this angle. And that might be a little bit alarming because the angle's outside of the triangle, but can you see these Z angles here? They're actually equal, so they're alternate angles, and alternate angles are equal. So this angle here is 34 degrees, and that's actually the angle of elevation from the boat up to James. So the angle of depression and the angle of elevation are actually equal. So You can start off doing the angle of depression out there, then you just bring it down inside the triangle here. And now we're back to using SOHCAHTOA to work out what this distance is along here. So which sides do we have? We've got opposite and we've got adjacent, and that is tan. So tan 34 is equal to 120 on x. So again, it's one of those ones with the pronumeral on the bottom. Do you remember what we do? We switch the tan 34 and the x. So x is 120 on tan 34, put it in the calculator, and we get 178 meters. Okay, we're going to move on to trigonometry in 3 dimensions, and we'll start with finding the angle between a line and a plane. So consider the rectangular prism below. Each of the faces of the prism is a plane, so they're 2-dimensional. We want to find the angle between the line EC, that's the yellow looking line there, and the plane FGHE, which is this bottom surface here. Now currently we can't do it. I'm just going to highlight that bottom surface so that you can see it. Currently we can't do it because all the lines that are on that bottom surface are not in the same plane as this diagonal. So we've got EH, which is 10 centimeters, and they do meet at a point, but this one heads out this way and this one heads straight along, and we can't use that length either. What we've got to do is get one in the same plane as EC, and that's going to be the diagonal between E and G, this one here, and we're just going to use Pythagoras' theorem to work out that length there. Here's the right angled triangle here, and that's the hypotenuse. So EG squared will be 10 squared plus 4 squared, which is 116. EG will be the square root of 116, and I'm going to leave it in exact form. So now we can find the angle. So let's see what we've got here. I want this angle here, and looking at that triangle that goes right the way through that prism, I know this side up here is 5. I know this diagonal here is the square root of 116. And so what sides do I have? I've got the opposite side and the adjacent side, and so it is tan. So tan of x, or whatever pronumeral you want, will be equal to 5 over the square root of 116. So I need to get x by itself. This tan has to go over the other side. It comes over as tan to the -1, and we do shift tan on the calculator. So when I do shift tan of 5 over the square root of 116, I end up with 24.9 degrees. Let's look at a harder question. Hester wishes to measure the height of a tower. She measures the angle of elevation from 2 points that are 100 meters apart. From point A, which is due west of the tower, this is the tower here, the angle of elevation is 23 degrees. From point B, due south of the tower, the angle of elevation is 38 degrees. I should also mention that these 3 points, A, B, and the base of the tower, are all on level ground. I didn't have really enough room to write all of that. Okay, so let's introduce some pronumerals. Firstly, the height of the tower can be h, and then I want this distance here to be x, and this one to be y. All right, let's have a look at how we do this question. Let's consider this triangle first of all. It's a right-angled triangle, and so I can do trigonometry on it. All right, what sides do I have? Opposite and adjacent, so it's tan. Don't be too alarmed about the fact that I have 2 pronumerals here. It's kind of going to be like simultaneous equations. I'm going to make x the subject, so I'm going to bring the x up there and the tan 23 down here, like that. All right, let's leave that alone for a minute, and let's consider this triangle here. This is also a right-angled triangle. Let me just get rid of that little right angle and draw the other one in. And it's going to be tan as well. Tan 38 equals h on y. So let's do that. And now make y the subject. So y is equal to h over tan 38. Now we're going to look at the bottom triangle. So that's this triangle here. And this one is also a right-angled triangle. And it's a right-angled triangle because this is due west and this is due south. And they're 90 degrees apart. So I'm not going to do trig on this particular triangle on the bottom. I'm going to do Pythagoras' theorem. There's the hypotenuse. So 100 meters squared, or 100 squared, will equal x squared plus y squared. I know what x is, it's that. I know what y is, it's this. So substitute that in. And now we've just got to solve this. But we're going to use the graphics calculator to solve it, which is going to be very nice. So we're going to do equation solver. So if you go into equation solver, it's a bit of a pain in the neck to put in. You put in the x over tan 23 and square it, plus x over tan 38, and then square it equals 100 squared. When you press solve, you get 37.3. And so the height of the tower is 37.3 meters. All right, let's move on to non-right angled trigonometry. So when triangles are not right angled, there are three formulas that we can use. We can use a special area of a triangle rule, which we'll do first, instead of a half times base times height. Or we can use the cosine rule to find an unknown side or angle. Or we can use the sine rule to find an unknown side or angle. So for non-right angled triangles, we use this area formula, a half AB sine C. Here's an example, find the area of the triangle. So our formula is a half AB sine C, but we can see that there are no letters on any of the vertices on the triangle. So what we're going to do is make our own letters. The formula says AB sine C, there's only one angle. So there's only one angle in the triangle, I'm going to make that angle C. Now if you remember way back from year 7, I think you would have learned how to label triangles. Opposite the angle has the same letter. So this is little c. Now I can label the other two however I want, it doesn't really matter. I'm going to label this one here A and this one B. And that means that this is little b and this one is little a. So now I can substitute in the formula. So a half times 7.56 times 7.91 times sine 50.7, and we put it in the calculator and we get 23.1 centimeters squared. Moving on to the cosine rule. The cosine rule can be used to find unknown sides or angles in non-right angled triangles. And there are two versions, both of them are on your formula sheet, depending on whether you want to find an angle or a side. So this is the formula we use to find the side, and this is the formula we use to find the angle. Okay, so let's have a look at an example. Find the value of x. So here's our formula for finding the side, and we have no letters on the vertices, so we're going to put the capital A where the angle is, like this. And that makes this here little a, and it doesn't really matter which way around I do the others. Let's have a look. I've got b as 14, so I've made this b, which makes this little b, and this one's c, which makes this little c. So substituting it into the formula gives us that. Put it into the calculator in one go. That gives you 81.058. Now, does this remind you of anything? It's a little bit like Pythagoras' theorem. Remember at the end of Pythagoras' theorem you've got to do the square root? It's the same here. So this 81.058 is x squared. We don't want x squared. We want x. So we'll do the square root, and so the side length there, x, is 9. Let's have a look at this one. Find the length of side AC. This one's got a bit of a dilemma. Here's my formula. Do you know what the dilemma is? The letters are wrong. See, I've got angle B there, and my formula says angle A. So you've got two choices. You can either rewrite the formula. You would be rewriting it as b squared equals a squared plus c squared minus 2ac cos b, or you can change the letters on the triangle. I'm going to do that. So let's change this b, we want it to become an a, which makes this little a. This can change to b, which makes this little b, and c can stay the same, and that makes that little c. And now I can substitute it in the formula. In it goes. On the calculator gives us 27.715 square root, and so the value of AC is 5.26 centimeters. When we're finding the value of the angle, we use the other formula. So here's our first example. I need to put in the letters. So here's going to be capital A for the angle, makes this 45 over here, little a. I'm not going to put in the other angles, I'm just going to say that this one can be B, and this one can be c, because it doesn't really matter. This is plus here, and this is times, so it doesn't matter which way around we get them. So 82 squared plus 110 squared minus 45 squared all over 2 times 82 times 110. That gives us 0.9312. Now remember, we want to find a, not cos a. So to get rid of that, it's going to go over the other side as cos to the negative 1. So a is equal to cos to the negative 1 of 0.9312. And that is 21.4 degrees. Here's another one where the letters are in the wrong place, so we're going to change it. There's our formula. We want the size of angle ABC. ABC, we want that angle there. I'm going to mark it to begin with. Alright, so he's going to become angle A, which makes this little guy A, and I just don't care about these ones at all. So I'm just going to make them B and C in either order. Okay, so substituting it in, 4.1 squared plus 6.3 squared minus 6.4 squared all over 2 times 4.1 times 6.3 gives us 0.3008. Shift cos gives us 72.5 degrees. The sine rule is used when you have two sides and two angles, so it's a little bit different. And again, like cosine rule, there's two versions. This is the angle version. This is the side version. Okay, so let's have a look at how we find the length of side AC. So that's this side here. Now, I'm not going to actually worry about the formula with this one because it's just so intuitive, the sine rule. You put the thing that you want on top on the left-hand side, and then you pair it up with its sine of its opposite angle. And then you're going to make that equal to the other side length divided by sine of its opposite angle. So you make two pairs out of it. So this is what it is here. I've used AC instead of the X. But can you see what I've done? AC over sine 65.3. So they're a pair. Equals 4.8 over sine 44.3. It's very like similar triangles where you match up the sides and make a proportion statement. So AC over sine 65.3 equals 4.8 over sine 44.3. I want to get AC by itself, so I want to move this over the other side. It's going to become a times 65.3 and put it in the calculator, and we get 6.24 centimetres. Well, what if the sides and the opposite angles don't match up? Like in this case. So here I want to find the length of BC, so that's this length along here. And it's got no matching angle. Can you see that? I've got one pair here. It's not very difficult to find this angle though, is it? Because I know the angle sum of a triangle is 180 degrees. So angle A will actually be 180, take 44.3, take away 65.3, which is 70.4. So now that I know that that angle up here is 70.4, I actually can do the question using the sine rule. So I take the thing I want, which is BC, divide by sine of the opposite angle, equals, find the other side, 4.8, and divide by sine of the opposite angle. Let's take the sine 70.4 over the other side. BC is equal to 4.8 times sine 70.4 divided by sine 44.3 equals 6.47 centimetres. Let's find an unknown angle. Find the size of angle ACB. So that's this one here. So again, pair them up. Put the thing you want, which is in this case sine C, at the top on the left-hand side. So it's going to be sine C over 4.8 equals the other angle, sine 39.2 divided by 5.9. Get rid of this 4.8. That's a divide 4.8, so it comes over here as the times. So sine C will be 4.8 sine 39.2 divided by 5.9. And remember how we want to get this sine to come over, because we only want it the size of the angle. It comes over as an inverse sine. So shift sine 0.5142 is 30.9 degrees. How do we know whether to use the sine rule or the cosine rule? Sometimes we're given a question where it doesn't tell us. We know looking at both of those triangles we're not going to use SOHCAHTOA because they're not right angled. But what's the difference between sine and cosine? It's pretty easy actually. This is the sine rule down here, and I can tell because it's got two angles. And we match them up with the sides. So this one's sine. This guy over here is cosine. He's got one angle and three sides. And so this one's cosine. The calculator has a limitation when it comes to obtuse angles in the sine rule. Do you remember what obtuse angles are? They're angles between 90 and 180. So in the triangles shown below, the calculator will give the same answer for angle EFH, which is this one, and EGH. And they're obviously not the same angle. Let's have a look what happens. I've split the triangle up into the two different triangles. Let's do this one first. I'm going to do sine theta over 6 equals sine 46 over 4.7. Move the 6 over, becomes a times 6. Sine theta is equal to 6 sine 46 on 4.7, and then do shift sine, and I get 66.7, which is correct. Now, when I do this triangle here, I do sine alpha over 6 equals sine 46 over 4.7, which is actually identical to the other equation. Can you see that? So no wonder I get the wrong answer. Times by 6. Sine alpha is equal to 6 sine 46 on 4.7, but in this case alpha is not equal to 66.7. I can tell that it's not because it's an obtuse angle. So why does that happen? Alpha is actually equal to 180 minus 66.7, which is 113.3. If you put both of those numbers in your calculator, look at that. Sine 66.7 is equal to 0.9184463.813, and so is sine 113.3. And it's because sine is cyclical, okay? It repeats. Have you ever seen a sine wave? So it has various points on it where it's equal to the same thing, but the calculator stores only one. So when we do shift sine, it only gives us the acute angle. So it'll only ever give us 66.7. So you've got to keep an eye on whether you want the obtuse angle or not. If you've got a question like this, it'd be towards the end of the paper because it's quite a difficult concept. It doesn't happen with cosine. You don't have to worry about cosine at all. It's only peculiar to sine. Okay, that brings us to the end of the trigonometry part of the course. So I'll see you in the next video.